Hello, Mr. Lopriato here. We're going to try something out within the honors chemistry where we're going to make some of these videos to kind of go over some of the things that maybe are either hard in class or things that we're not going to be getting to in class, just kind of supplement. So today I'd ask you guys to read chapter 3, sections 3.1 and 3.2. That's on matter. I'm not going to be going over this in class, so that's why we have this video. First off, we know that everything is matter. So what I want to talk about in this video is classifying matter. All right. Now, I was thinking about this over the weekend. As a kid, if I was sick, I would have to stay home at my grandma's, and she was a seamstress, so she had a big thing of buttons, and I would go through and I'd classify all the buttons. So that's kind of what we're doing here. So we're going to take everything in the world, and we're going to make different categories that it exists in. So the first question we're going to ask ourselves about matter is it pure or not? And when I say pure, it means it cannot be broken down by ordinary physical means. All right, so either something is pure or it's a mixture. All right, we just did a quiz. We looked at those element names and symbols. All of the elements, they are pure, right? There's nothing else going on there. And any chemical compound is also pure. But then a mixture is when we have two or more pure things kind of mixed together. All right, examples of mixtures would be like the sand at the beach, or mud, or pond water, stuff like that. So we have pure substances, we have mixtures. Now if we were to classify the pure substances further, we either have elements, and an element has to appear on the periodic table. If it's not on the periodic table, it doesn't count. Or when we have multiple elements chemically combined, those are compounds. A great example of a compound would be water, all right, also called H2O. We don't see water on the periodic table, we don't see H2O on the periodic table, but we see hydrogen and we see oxygen. So those are the elements. They are pure elements and there are pure compounds, all right, two or more elements chemically combined. So that's on the pure side. On the mixture side, we have to ask ourselves another question. We have to ask ourselves, is the mixture, does it have an even consistency, or is the mixture kind of uneven? So if that mixture is uneven, we're going to call it heterogeneous. And if the mixture is even, we're going to call it homogeneous. All right, an uneven mixture, a heterogeneous mixture, a great example, a salad. If I brought a salad to the class and I scooped a little bit on everyone's plate, no two people's plate would be the same, right? Everyone's mixture would be a little bit different. Someone's gonna have more tomatoes or more cucumbers or something. There's different pieces in that mixture and there's no consistency, there's no order. Now, an even mixture we're gonna call homogeneous, we're also gonna refer to as a solution. So to have that even mixture, something has to be dissolved in something else. So something like a bottle of soda. If I pour 5 cups of soda, everyone's cup is gonna have the same mixture in it. Now that soda, it's got all these different things, right? It's got the water and sugar and the carbonation and all that good stuff. But if I were to pour it into different containers, it's the same mixture. So it's even. All right, so that is just classifying matter. It's either pure or it's a mixture, and we can take it one step further. Element, compound, heterogeneous, and homogeneous.